Okay, so we're looking on page 603 in the blue book, problem 941. So you guys, I do believe it's one bottle. So you guys, the square root of 1 is 1. So that is going to be like our normal curve. So let's just go ahead and do that. So it says a bottling company uses a filling machine to fill plastic bottles with the cola. The bottles are supposed to contain 300 milliliters. In fact, the contents vary accordingly to a normal distribution with mean mu of 298 milliliters and a standard deviation of 3 milliliters. What is the probability of individual? Okay. So, first of all, let's talk about whether we can do this problem or not, okay? So there's a couple things that it gave us. So I just threw a fit about CLT, right? You only use it with means. They gave us a mean. So we need a sufficiently large sample size. Well, our sample size is only what? 1. Okay, well, that doesn't work for CLT. But in the problem, it says that it says the contents vary according to a normal distribution. That right there takes care of anything that we need now. So there's 2 ways to prove normality. And this is the same thing with proportions, okay? If it says it follows a normal distribution, it's approximately normal, then it's approximately normal. You proved it. You don't need CLT and you don't need the N times P, okay? So, you guys, I want to make sure that you're drawing your pictures, okay? A picture on a free response question, if you do something wrong, but you draw the picture right, that will save you, okay? So let's put 295 in the middle. I know my normal curve looks horrible, and I apologize. So 295 goes here. And then our standard deviation is 3, right? 298. Is it 298? I'm sorry. Yeah, sorry. Yes, it is 298. I apologize. Okay, so 298 plus 3 is 301, right? 304, 307, 295. Ooh, that's a nice one. 292, and what? 280. Thank you. And they want to know what is the probability that an individual bottle contains less than 295. Less than. Okay. So what do we need to do?
Find the z-score.
Find the z-score. Go ahead.
Isn't that it's on the
Yep.
one standard deviation?
You can do either one.
Okay.
Yep. So you can either find the z-score or look it up, or you can know that it's 1 standard deviation. So how much is it? If not, find the z-score. So we found the z-score. The z-score was -1. We looked up -1. We got 0.1587. You could have also used 16% and not gotten in trouble because that's the empirical rule. The probability that an individual bottle contains less than 295 milliliters is 0.1587. Okay? So that's part A. And this is problem 9.41. Okay, now we're going to do B. We're going to complete B. B says, what is the probability that the mean content of the bottles in a 6-pack is less than 295 milliliters? Show your work. Now, what do we have? our n is what? 6. Up here, our n was 1. But down here, our n is 6. So now, our standard deviation is going to be affected. So, again, you guys, it doesn't matter that the sample size is 6 because our problem says that our distribution is approximately normal, okay? So we're going to do 3 divided by the square root of 6 for our sigma. And what do we get? Yeah. No, it's going to be for our sigma. We'll talk about that in a second. Because it's put standard deviation for now. Because I'm going to change that up in a couple days anyway. So just put standard deviation. What is 3 divided by the square root of 6? 1.2247. Okay. I don't mind you when you go to do your normal curve, if you don't want to add all those decimals, I get it, because it's kind of tedious. But you need to make sure that when you're showing them that you round out. Why is it important that we're going out 4 decimal places?
Be more specific.
It's going to be more specific. It's less round off error. I understand drawing the picture. You don't want to put all the numbers in. I get that. But you can't just round this and say, okay, it's 1.2. That is too much round off error, especially when we get to our next section and we're talking about those p-values. You really need to make sure that you're rounding out to 4 decimal places. Okay. So now we're going to draw another picture. And you guys, again, my picture is not great because my standard deviation is so small that it should be a little bit taller and narrower. Okay. Okay, so we did the normal curve, we shaded it, we found the z-score, which was negative 2.4496. The table only goes out 2 decimals, so we rounded it, and we looked this up, and so 0.0071, now we need to write that. We need to write that sentence, okay? The probability that a 6-pack is less than 295 milliliters is 0.71%. So, just to recap, that if on a free response question you are running out of time, you may skip the picture, but the sentence you cannot. You always have to tie it back into the problem. You always need to make that connection between your answer and what they're asking you, okay? This would give you points, but you would lose 1. Kind of like if you use X bar and you should have used mu, you lose a point. If you use CLT and you weren't supposed to, or you don't use CLT and you were supposed to, they'll take a point off. So when I talk about a free response question, what I'm really talking about is I need you to make, if you're going to make a mistake, everyone laughs at me, but let's make it a big one. I have no idea what I'm doing, okay, but I know this is supposed to be mu. Don't lose a point on that. Don't lose a point on CLT, because there's going to be things that you know how to do, and you might not know how to do some other things. If you're going to lose a point or you're going to lose points, let's make them big things that you're going to lose a point for, not small things like CLT, X bar, instead of using X bar when you should have used mu, stuff like that. I didn't feel like writing a sentence. If you don't feel like writing a sentence, you are going to, that's not a big point to me. That's a small point, because you always are going to have to write it back in context of the problem. Okay? So, it's going to ask you, again, in a problem, it's either going to give you a sample size, or it's going to tell you that it follows a normal distribution. The sample size has to be at least 30 to use CLT. And CLT states that if your sample size is sufficiently large, And when we write that, that's how you would write it. CLT states if your sample size is sufficiently large, 30 or more, we have 30 in our sample, then our distribution is approximately normal. Or you're going to say the problem states that our distribution is approximately normal. So those are the two ways you can get CLT. The problem states or either normality, either way for normality. The problem states it or you have to use CLT. Okay, so let's do another problem. Okay, so we're gonna work on page 609 in the blue book. Brick and mortar kids, make sure you've taken a picture of it because you don't have that book. Blue book right here. You're going to do B and C. I'd like you to look at A though and think about that question just so we can talk a little bit about it tomorrow. So let's just make sure we understand. So everything is going back to the normal curve, to that normal distribution, okay?